We're going to look at solving rational equations and inequalities. Once again, rational means it's a fraction. So we're going to look at solving equations where we have variables in the bottom of our fraction. So the first thing you want to do is to find your LCD, and we've done that before. You got to factor all your denominators. And then you find your least common denominator, so you write down all the different terms that occur, and if you have a choice in exponents, like we do on our 2, either a 2 squared or a 2 cubed, you always take the larger of the exponents. Then we're going to multiply by special forms of 1, and remember, multiplying by 1 doesn't change it, so that we can get our least common denominator. So this first fraction, top and bottom, needs an x minus 3. So what's in red is a special form of 1. This next fraction needs a 3 and a 2 cubed, top and bottom, which that purple is a special form of 1. On the right-hand side, we need a 3, a 2, and our parentheses. So what's in blue is a special form of 1. And once again, multiplying by 1 doesn't change it. So we can write it all with the same denominator. So we would get this here for our first part, plus, and then this here, we would get this, and then equals what we have here on the right. Since everything has the same denominator when it's an equation, this does not work with expressions like we were dealing with earlier in the chapter. If it's an equation, then you can just set the numerators equal. This plus this equals that, and then solve it. So now all we have to do is just solve it like normal. Distribute through, multiply stuff out, get the x's on one side, and we get negative 45. And in this case, negative 45 is our final answer, but we should always check to make sure that the answer we get doesn't cause us to divide by 0. If I take 3 minus 45, it's not 0, so I know that's going to work. Here, same type of thing. We got to find our LCD. So we got to factor all the denominators first. Find our LCD, which is all the different things that show up in the bottom. We don't have choices on the exponents. So that's our LCD. We want to try to get that LCD on each and every fraction. Our first fraction needs an x minus 1 top and bottom, which is once again a special form of 1. Our first fraction on the right-hand side here already has our common denominator, so we don't have to change it. Our last fraction on the right-hand side only has a denominator of 1, so it needs both of those, top and bottom. So everything in the blue is a special form of 1. Multiply these first two together. Equal sign. Bring down the next fraction because it already had nothing we had to change. Plus, and then multiply the last two together. Last two fractions, that is. Now that everything has the same denominator, we can go ahead and just work with the numerators. We can bring this down, and then we can bring this down. Over here, we can bring this one down. All we have to do now is solve this. So we could take p squared times p n times minus 1, negative p times p n minus 1, and 1 times p n minus 1. And then we would get this when we collect our like terms. Here we could distribute through FOIL and then distribute, and we would get that. Now we can go ahead and try to get everything on one side. We could subtract the p cubed from both sides. They're going to drop. Negative 2p here, so we'd have to add 2p to both sides. 2p here, have to subtract a 2p from both sides. And then we'd have to get the 1 over there and subtract, or add 1 to both sides. So we get a nice normal quadratic. Remember, in solving quadratics, you want it set equal to 0. And then you could factor it, and that only sometimes works, or you can always use quadratic formula. This one factors nicely. Remember, the first step in factoring is greatest common factor. And then you could do AC factoring on what's left. We can set this parenthesis equal to 0, this parenthesis equal to 0. We don't have to worry about the 3 being 0, because you have 3 things multiplied together to give you 0, Our 3 has no variables by it, so it's never 0, so we don't get anything from that. However, our only answer is 2. If we take -1 and plug it into our original problem up here, p being -1 plus 1 gives you 0, and we can never divide by 0. So that -1 is something that we got from doing correct work. It's referred to as an extraneous solution, but it does not work in your original problem. So try this one and then watch the video. Factor, find your LCD. Multiply by special forms of 1 to get your least common denominator. Write each thing as one fraction. Bring that one down, write that as one fraction. Everything has the same denominators, so just work with the numerators. Solve it. And we get 7/3. And then you'd want to double check to make sure that that doesn't cause you to divide by 0. 7/3 minus 2 is not 0. 7/3 plus 4 is not 0. And this one here in the center, you could factor it and look at it in here. It's easier to plug the numbers in. Neither one of them are 0. So how about solving inequalities that are rational? Well, it's somewhat similar. You still need to find your LCD, but for the most part, we're going to leave this inequality. We're going to switch it to an equal sign and work with that. And then we'll deal with inequality here in a bit. But doing that's going to allow us to find what we refer to as critical points so that we can find the spots in our number line that work and don't work. First of all, I would start out by looking here and saying, oh, what causes the bottom of any of these to be 0? In that case, that's 0. So S not equaling 0. So 0 is a critical point that we'll have to put on our number line. We'll find our LCD. Our least common denominator is 9S. Then we'll want to go ahead and do special forms of 1 to get 9S for all of our denominators. First fraction needs a 3 top and bottom. The last one on the right-hand side needs a 3S top and bottom. Write everything over the same denominator. Everything has the same denominator. You work with just the numerators, the tops, then solve it, and we get this. So S being 0 is one critical point. S being 5, 6 is another critical point. All we're going to do now is go ahead and put those on a number line. Now, 0 and 5/6 divide our number line into regions that work and regions that don't. So what you can do is go ahead and try numbers from each region to see what works. So over here on the left, I'm going to try -1. If I plug -1 in for S, I get -1/3. If I plug -1 in for S, I get -2/9. And a negative plus a negative I know is a negative, which would definitely be less than a positive, which is over here. So I tried a number over here and it worked. So that's where I'm going to shade. I could try a number in between, like a half. So if I try a half, three times a half is 3/2. 1 divided by 3/2. Instead of dividing by a fraction, you multiply by the reciprocal. Here, I'd have a 9 times a half, which is 9/2. Instead of, if I can talk here, sorry. Instead of dividing by a fraction of 9/2, I multiply by the reciprocal and I get 4/9. 2/3 plus 4/9 is obviously going to be bigger than 2/3. I need it smaller, so I tried a number in between and it doesn't work. I could try a number over here like 1. So I could try something larger than, try that again. Why are we not writing? There we go. Try 1 over here. Be 1/3 plus 2/9 which would be less than 2/3. So it does work, so I need to shade over there. So now I can write my answer off of my number line. I have two totally separate regions that work, so I need to write it as two totally separate inequalities. What's to the left of 0, or what's to the right of 5, 6? So try this last one on your own, and then go ahead and watch the video. Find your LCD, which is 5x. Also, take what's in the bottom, set them all equal to 0 to find what you cannot use, which in this case happens to be 0 again. Multiply by special forms of 1 to get your least common denominator of 5x. Write each thing as single fractions. All the denominators are equal, so you can just work with the tops. Then you do a nice normal solving like normal. So now we have our critical point of 0, and we have our critical point of 4 that we just came up with. So now we have to put those on a number line, and it divides your number line into regions that work and regions that don't work. So I'm going to try a number over here like -1. Plug in -1 here, I get -1. Plug in -1 here, I get -3/5. A negative plus a negative is even more negative. So if the left side's negative, we obviously know it's not greater than 2/5. So we tried a number here, it did not work. So we can get rid of that. We can try a number in between, say maybe 1. So if I try 1 here, 1 plus 1 over 1 is 1, plus it'd be 3/5. 1 plus 3/5 is greater than 2/5. So I tried a number in between and it worked. So I'm going to shade there. I could try a number to the right over here. I could maybe try something like 5, because that's in that region. Then it would be a 1/5 plus a 3/25. 1/5 plus 3/25 is not greater than 2/5, so it does not work. So now I have only one region, so I could write it as one compound inequality. I'm going in between 0 and 4, so I put my variable in between 0 and 4.